Hello, my name is Paul Box, and I work for the Commonwealth Scientific Industrial Research Organisation, CSIRO, which is Australia's national science agency. Before I begin, I would like to acknowledge the Gadigal and Wangal people of the Eora Nation as the traditional owners of the land on which I'm speaking to you today, and pay my respect to their elders, past, present, and emerging. So I'll be talking to you today about some work we're doing looking at improving the capture, flow, and use of environmental impact assessment data in Australia, and some of the implications of the work that we're doing for Indigenous data. So my talk today will cover two main topics. Firstly, I'll briefly describe a project we've been undertaking to redesign a national environmental assessment data system to improve the capture and use of environmental impact assessment data generated by development proponents. Secondly, we'll then talk a little bit about Indigenous knowledge in the Australian context and some of the environmental management challenges that we face. And I'll end by posing a couple of questions around issues related to the use of Indigenous data knowledge for environmental management in Australia. In Australia, mining accounts for 6% of GDP and is a significant economic activity. A lot of mining occurs on Aboriginal land in the Northern Territory, Western Australia, and elsewhere. And it's estimated that about close to $40 million is spent each year collecting biodiversity data within Western Australia as part of environmental impact assessments conducted as part of the process of seeking approval for new development. And much of this data in WA is generated through extractive industry, through mining activity. So CSIRO was asked to explore the issue of how much environmental impact assessment data is generated and how much of that data is actually shared with government. This work was undertaken as part of a broader review of the Environmental Protection and Biodiversity Conservation Act, which is national legislation in Australia to protect matters of national environmental significance. These are things such as World Heritage properties, listed threatened species and ecological communities, Great Barrier Reef Marine Park, and water resources in relation to coal seam gas and coal mining. So as part of this process, we identified 20 case studies. And for those case studies, we looked at the documents that were lodged by development proponents with government as part of the a referral, environmental assessment and approval process. What did we find? We found lots of documents. So for the 20 cases, 522 documents in total, and no data lodged. So the documents were a PDF and Word doc formats, which technically could be considered as a form of data, but we found that there was no structured data lodged. So we did find that there were lots of inferred data sets within the documents. So within reports that were lodged, there were tables and graphs and maps which showed environmental information. And from that, we inferred the existence of a number of data sets, 223 fauna data sets and 173 flora data sets that were inferred in the production and lodgement of those documents. There are other kinds of data, cultural heritage data, a small amount, hydrology, landform data, etc. But flora and fauna, biodiversity and ecological survey data was predominantly the form of data. So based on the findings of the document analysis and a subsequent review of environmental impact assessment processes in each of the states and territories, we came up with some fairly simple recommendations that rather than lodging documents, proponents should be required to lodge data into government systems. In the next phase of the system, we looked at the types of data that were collected through environmental impact assessments and the ways in which that data are stored and how they flow through government systems. The two key types of information collected were ecological survey data and species occurrence data. So ecological survey data are more comprehensive studies of ecology, looking at things like structure, function, composition of the ecosystem, hydrology, soil, etc. Whereas species occurrence observations are either single records of species that have been observed through targeted surveys or through ecological survey. These data are typically stored in lots of different systems within proponents' organizations, and then some of it gets lodged into government, but typically again into different systems. And the data tends to get a little bit fragmented, and we lose some of the context of the environmental understanding because of the way that data is fragmented and stored in different systems. Reviewing the environmental impact assessment processes in more detail, we identified the really critical role of natural history collections maintained by museum and herbaria in supporting environmental impact assessment and underpinning our ability to continually improve and evolve an understanding of biodiversity and ecology. Taxonomic classification is constantly refined based on new scientific understanding, and this in turn is developed through new samples and research based on them. And a lot of new samples are being collected through environmental impact assessment. Natural history collections will play an increasingly important role in the field of environmental genomics or environomics. Using genetic approaches, we're able to see beyond the landscapes to its genescape to reveal and make use of genetic resources. The curated natural history collections and the new samples taken through field surveys provide the raw materials for the development of genomes for species. This in turn supports the use of emerging environmental DNA or eDNA approaches that enable the identification of species from the DNA traces they leave behind in water, soil, and air samples taken at specific locations. eDNA, though an emerging approach, has potential to radically transform environmental assessment, but also raises some really significant implications in terms of the rights over data and genetic material. So through this project, we identified what the current state of the system looked like: a series of fragmented data systems across government with limited proponent data flowing into those systems, and articulated with a whole range of stakeholders a future vision for a more integrated system. We also identified a couple of key priorities that would enable us to move from current to future state. And some of these have potential implications, a potential application to assist in addressing some of the challenges associated with Indigenous knowledge, integration and use. So the four main recommendations we made were around identifying priority data, agreeing on what data we wanted to exchange, understanding that there was a need to refine institutions to require proponents to lodge data into government systems, the development of standards so that we could link and exchange data between systems in consistent ways, and then the design of application programming interfaces, the technical mechanisms that would allow us to connect the different systems together. So when Australia moves to improve the capture, exchange and use of proponent environmental assessment data, reflects the way that we increasingly think about the value, rights and control over data, and the desire to increase the openness of data. And in the context of EIA proponent data, we're in a sense moving from extractive to more generative models of data production. In an extractive model, the aim is to mine a resource for private benefit. And in the digital world, in environmental impact assessments, this means that proponents collect data, hold on to it, viewing it as a valuable resource that provides potentially a competitive advantage, or at the very least represents a sunk cost, and the value of which they don't want to share, and the benefit of which they don't want to share with others. From an economic theory perspective, this is a private good, and one can think of environmental data held in an enterprise data system of a particular organization as a private good. Moving to more generative models, we can think about public goods, and these are efforts to share as broadly as possible, to collate and aggregate and share as broadly as possible data for the public good. Data.gov, public data repositories are a good example of public goods. And in the context of environmental impact assessment processes, these more generative, collaborative approaches to sharing data enable the maximization of the utility of the data, both for proponents, potentially in reduced future survey cost, for the decision makers in improved quality of information in the decision, as well as in improved transparency. There's a third kind of good, a very interesting good in the digital realm, and one that's very relevant in the context of Indigenous knowledge, and that's club goods. And this is a model which is a kind of a more constrained public good model, in which members contribute data to a pot, and they communally control and decide who has access to the data and the rules of the club. And there are very many examples of community knowledge resources that are club goods. So how do efforts to improve capture and use of environmental knowledge through environmental impact assessments relate to Indigenous data? Well, from a Western perspective, we've been collecting and recording natural history information in Australia since the time of European contact and settlement, with the oldest record of an emu sighting, for example, dating back to 1770. Dating confirms Indigenous occupation of Australia for more than 50,000 years, and rock art serves to illustrate this deep time of Indigenous occupation and knowledge of the land. And Australian rock art painting of megafauna dated to 28 to 40,000 years ago is an early piece of information, environmental knowledge about land. Globally, Indigenous people have rights over about 25% of the global land surface. And in Australia, the Indigenous estate, held under a variety of different land titles and regimes, covers 40 to 60% of Australia, with as much as half of Australians' national reserve system owned and managed by Indigenous Australians. These rights haven't necessarily translated to economic benefit or adequate funding for appropriate management of country. Some protected areas are under governance of Indigenous peoples, others under state authorities, with a range of mixed models of collaborative arrangements for governance. The Indigenous estate is also in need of sustainable development options, as it's mostly in areas of high heritage, conservation value or world heritage, and increasingly susceptible to climate change, threatened species decline, and biodiversity threats, including invasive species. This is compounded by the fact that the Indigenous estate is also overlaps with resource extraction, mining, and pastoral interests, applying a lot of land pressure to the land. Asking Indigenous people to take on the burden of global conservation and environmental management without providing them with the adequate resources and institutional support to do this is really problematic. As we have seen, the scale of the Indigenous estate in Australia and the complex nature of the really significant environmental challenges require the application and maximization of the utility of data to address these challenges. In the systems and platforms that are built by government, academic, and private sector organizations, there are significant volumes of environmental, ecological, and biodiversity data. This data, because it relates to country, is in Indigenous data. And this data, if we're to apply this data and Indigenous knowledge, a key question, a primary question is how can Indigenous communities have a greater control over the recognition and use of this Indigenous data? There are several emerging rights management frameworks, traditional knowledge labels and biocultural labels. I won't talk about these. Maui Hudson is giving a talk about traditional knowledge labels, but they raise a number of questions around how are these labels to be applied, what are the institutional arrangements around systems and change processes around systems so that these labels can be applied. A second issue relates to the use of scientific knowledge and indigenous knowledge and the combination of these forms of knowledge to address land environmental challenges that we face today. So the question being, how do we actually bridge these different knowledge systems, indigenous and scientific knowledge? The example shown on the slide here is a fairly trivial example of using indigenous language names alongside scientific names within taxonomic classification. Indigenous ecological knowledge is highly interconnected with knowledge and understanding about specific species, interconnected with an understanding of country, seasonal indicators, plant ecology, soils, as well as cultural practices, ceremonies, rituals, and mythology, and the people who interact with and use the land. Given this deep interconnection, how can Indigenous knowledge be represented in digital platforms in ways that are consistent with an Indigenous worldview? Many platforms will represent Indigenous knowledge or data within their own internal representations or architectures of data in hierarchical taxonomic classifications, and this may necessarily not accord with Indigenous knowledge systems. A particular issue is how do we deal with this knowledge in data aggregation activities? Once Indigenous knowledge is represented in digital platforms, the next challenge is connecting up the multiple Indigenous data systems which will continue to exist and are necessary to capture and store this information. Key questions are, what are the social and technical architectures for doing this? Recognizing this is not just a technical interoperability challenge, there are some significant data rights, data governance challenges wrapped around in each of these individual community managed information resources. Finally, the rationale for the collation and curation of knowledge is for its application and use. And in this context, we can pose the question, how might Indigenous knowledge play a more significant role in addressing environmental challenges? What are the institutional arrangements required to enable this? A significant example of this is the use of traditional burning practices for fire-dependent ecosystems. The horrific fires, bushfire season 2019-2020, the last bushfire season in Australia, saw the loss of 10 million hectares of land, 80% forested, which was burned. And with this, a recognition of improved approaches to managing fuel load and the role of traditional burning practices to do this. Victor Stephenson, an Indigenous man, a descendant from the Tagalaka people of northern Queensland, in his book Fire Country, talks about Indigenous knowledge practices around use of fire, describes the role of fire in healing and ensuring the long-term health of country. He also talks about the role of healthy country in healing the health of people. However, environmental management happens within quite a complex institutional context of legislation, regulation, land title, land management practices, which are normative as well. And Victor Stephenson talks about the challenges of navigating these to enable burning practices on land. Following the recent destruction of 46,000-year-old significant Indigenous sites in Western Australia, Rio Tinto has joined forces with Indigenous groups calling for changes to relevant legislation that actually enabled this destruction to occur. The more widespread use of fire knowledge and other traditional Indigenous land management practices will require shifts in thinking amongst scientists, emergency management community, land managers and policymakers to enable and support these practices. Thanks for listening.